Next up, let's take a look at expressions and how to set up expressions using operators and operands. And let's start with some simple int or integer operations. So you can divide an integer by another int, and this is assuming that these are both ints. You can use the divide operator. Remember that if I1 is 9, 9 divided by -3 will give you -3. If I1 is 10, you will also get -3. Alright, so I hope that makes sense. If you divide a -7 by a 2, you get -3. So you don't get -3.5 if you divide a -7 by a 2. So that, I'm hoping, will make sense to everyone. Okay, so you can do the mod operator. Usually it only makes sense with a positive value on the right hand side of the remainder operator or the mod operator. So the way it works, if you have forgotten this, 0 mod 3 is 0, 1 mod 3 is 1, 2 mod 3 is 2, and then 3 mod 3 is 0. Right? So from that, I think you can work out why if you take -7 mod 2, you will get -1. So either side of the mod operator, you can have negative values. Most of the time we use for counting, and so most of the time the right hand side of the mod operator or the percent operator will be positive. But you should be ready for mod being the right hand side operand being negative. Okay, so this is all leading up to arithmetic expressions. These are expressions that evaluate to integer or floating point values. These can be built by combining literals or variable names with arithmetic operators. These are the common ones: plus, minus, divide, multiply, and remainder or modulo operator. You also have unary operators, that is, operators that work on one thing. So like the plus operator, as in +3, and minus operator will give you -3. Okay. Division makes sense, I hope, to everybody. We showed how if you have two integers, the result of dividing one integer by another is always an integer and it has no fractional part. So 2 divided by 4, these are both ints, you'll get a 0. Whereas 2.0 divided by 4.0, these are both double, and so we will use the Java compiler will send this operation to the hardware floating point arithmetic logic unit, which takes two doubles in this case and produces as a result a double, a value of 0.5. Okay, so this / denotes division when applied to two floating point operands, but integer quotient. So it is a little bit different. Integer division or integer quotient, it's the same thing. The important thing to keep in mind is that when you divide integers, you throw away the fractional part. If you mix them, remember that your promotion rules kick in, and let's say if you divide 2 divided by 4.0, you'll get a 2. The 2 on the left hand side over here would get promoted to a double. You do a double operation, you get 0.5. But then if you try to assign this value to an int, then there will be problems. But in general, if you say 2 divided by 4.0, the result is a double. Okay, remainder operator, we talked about it briefly. Primarily used with integer operands. 0 mod 5 would be 0, 1 mod 5 is 1, 2 mod 5 would be 2, 3 mod 5 is 3, 4 mod 5 is 4, 5 mod 5, that's where the difference occurs. 5 mod 5 would be 0. Also 10 mod 5 is 0, and so on. 15 mod 5 is 0. So I'm hoping this is clear. I'm hoping that everyone has seen this and remembers seeing this in your first year courses. Okay, so we actually looked at this. I'm going to skip this. I don't see anything that we need to look at in more detail. Promotion we talked about. So if you have something like 7 divided by 2.0, This means that the 7 will get promoted to a double, so that we can do this, so that Java can send this operation to the hardware floating point arithmetic logic unit. And so that piece of hardware is what does an operation like this. And it'll say 7 divided by 2.0 is 3.5. And so the result of this will be a double. Okay. So if you try to multiply an int by a double, same thing. The I1 int doesn't get promoted, it doesn't get switched to a double, but the value of I1 is promoted to a double. So if I1 has the value 10, it'll continue having this value 10. All that'll happen is that value 10 will be promoted to 10.0. You multiply 10.0 times 5, you get 5. Double precision, it's 5.0. Okay, so promotion, if you're not sure about it, definitely you should review it. Take a look at this and let me know. Well, take a look at this and see if you can spot if there are any problems. And you can pause the video if you want to get a chance to look at this, and I'll give you the answer. The thing to watch out for is that if you say 7 divided by 2, that'll give you 3. So I1 divided by 2 will give you 3. I1 times 0.5 will give you 3.5. Why? Because now you have a double precision number and an int. The int is promoted, and then I1 is not promoted, but the value in this is promoted. Value in this I1 variable is 7. 7 times 0.5 is 3.5, and you can print that out. Now it's a different thing if you try to do it over here. If you try to put I1 equals 0.5 here, you'll get a compiler error. Why? Because this whole thing is a double, and it's okay to print it, but if you try to assign that value to an int, Java, you'll say it'll give you an error message saying you're going to lose precision, and so you cannot do this. Okay, so here are the answers. Numeric promotion, we talked about this. So definitely, if any of these things don't make sense, you should either look it up, or talk to me during class or after class, or talk to your classmates. Probably some of them will know the answers. Okay, so when you look at an expression like this, if you have multiple operations, not just one operation, but multiple operations, and they'll come one after another, there's two ways to interpret this. One way is to say that you do it left to right. 5 minus 3 first, which will give you 2. 2 times 2 will give you 4. Okay, so that's one possible way to look at an expression like this. The other way is to say that, well, this is more, should have a priority, let's say. And so you get 3 times 2 is 6. And so 5 minus 6 will give you -1. So the two possible answers are 4 and -1. Which one is correct? So think about it, and what you need to look at is operator precedence. So there is an order of evaluation when you have any expression with more than one operator, and so it depends on the precedence of these operators. So you guys probably remember from Computer Science 161, 162 that multiply has higher precedence than minus, which means that when you evaluate this, you do this first. 3 times 2 is 6, and then you do 5 minus 6, giving you -1. So -1 is the right answer. So times or multiply, divide, mod, or remainder have higher precedence than plus or minus. Plus or minus are at the same precedence level. If you have two operators that are of equal precedence, like divide and multiply, then the operations are performed left to right. So 10 divided by 5 times 3. There's two ways to look at this. One is to say that 10, you do this first. 5 times 3 first, which would give you 15, and 10 divided by 15 would give you 0. The other way to look at it is, well, maybe this is done first. 10 divided by 5 is 2. 2 times 3 is 6. Turns out that the rule, so in this case and in previous cases such as this, you could say there's ambiguity. And what Java does to remove this ambiguity is to have higher precedence rules. It tells you there are specific rules that say that if you have operators of different precedence levels, you have to evaluate the ones with the highest precedence first. So in this case, you have to do this first. This is the order of evaluation. You do this, then you do the minus. So that's straight up application of these precedence levels. Now, when you come to a situation like this, if you have two operators with the same precedence level, like divide and multiply are the same, then you do left to right. So you do this first. So these rules, all they do is remove any ambiguity. So you don't have to second guess. What will Java do? Will it do this first or this first? No, there is no ambiguity. Java has these specific rules to make sure that anytime you write any expression, it's completely certain exactly what the value of that expression is. Okay, so multiply before add, that's a important one. So you do this first, you do this first, divide before add, you do this first, and so on. If you see a minus 5 plus I1, this is interpreted as being negative 5. Okay. Same thing now with minus signs. Let's say 5 minus 3 minus 2. There's two ways to interpret this. One is to say 5 minus 3 will give us 2, and 2 minus 2 will give us 0. The other way to interpret this might be to say, well, maybe you do this first. 3 minus 2 is 1, and so 5 minus 1 will give you 4. So what's the right answer? 0 or 4? It turns out the rule that's applied is that when you have two operators at the same level, you go left to right. So you do 5 minus 3 first, that's 2, minus 2 will give you 0. So the correct interpretation is, in that case, was left to right will give you 0. Okay, so once again, divide and multiply, you go left to right. So I1, let's say it's 10. 10 divided by 5 is 2. 2 times 2 give you 4. And so on for all of these. These are all in situations where you have the same operators at the same precedence level. You evaluate things left to right. Okay, quick word on casting. Every once in a while, you might have to convert a value to a different type to be able to perform certain operations. So for example, 10 divided by 40 will be 0. However, if you want the fractional part, you can convert just one of them. Actually is enough, but it's a good idea to do both of them. Convert the 10 to a double, the 40 to a double, so it's 10 divided by 10.0 divided by 40.0, which will give you 0.25, and this way we get the fractional part. So it depends on what you want. Sometimes we want the fractional part, sometimes we don't. Okay, so you can do this with ints. We can cast it to a double. If you cast one side of a divide operator, for example, then the other one is promoted. So if you do 10.0 divided by 30, you promote the 30 to a 30.0, and then you get a double precision value. It's always good to explicitly put a cast operator here on both sides. It's always good to do that. It's not required, but it's probably a good thing to do. And you want to be aware of which order you do things in. So for example, if you do a double I1, that's you casting that I1, and that has precedence. This casting operator has precedence, and so this converts the I1 to a 10.0, and this whole thing is a double. However, if you put parentheses around this I1 divided by I3 as shown here, and these are both ints, assuming these are ints, you get a 10 divided by 30, which gives you 0, and then you convert the 0 to a double, which gives you 0.0. It's very different from 0.3. So you do want to be aware of that. The order in which you do things is pretty important.